Hello, here's chapter 2, video 3, talking about the class notes. Again, these are the short videos to give you an idea of the solutions of the class notes. But you can always watch the full videos, which is the full lecture of everything. This is really a quick overview of the solutions. So, in this video, we're going to talk about this problem where we do quadratic regression. So the following table shows the total population, U.S., state, and federal prisons from 1970 to 1997. So our input is year, and our output is population. I'm just going to use this example to show you the calculator, how to do show the data and the quadratic regression through it. Then we'll do another problem below where we'll spend more time on it. But for right now, we're just going to practice doing quadratic regression. It is very similar to linear regression. So we're going to go to the calculator, and we'll make sure we start with a clean calculator. So what that means is I'm going to turn it on, go to y equals, make sure there's nothing in y1 or y2. Make sure your plots are off. It means all these are unhighlighted. If something is highlighted, go up to it, push enter, and then unhighlights it. And then we're going to put the data in the calculator. So I'm going to hit stat, number 1 for edit. This is very similar to what we did with linear regression. So we're going to put our data in the calculator. So we have 0, 3, 6, 9, 12, 15, 18, 21, 24, 27 as our list 1. That would be our X. And then in list 2, we have 0.18, enter, 0.18, enter, 0.26. Double check that all the data is correct. If one number is wrong, it could mess up your data. Okay, and make sure everything lines up. If one list is longer than the other one, you may have issues. So the first step is I would always sketch by hand. And what I mean by that is input is years, output is population. It looks like a scale would be from 0 to maybe 30. It looks like counting by 3s is good. You decide that. And then maybe for population 0 to 1.5 or 2, maybe counting by 0.25s. But sketch it first. Window is very important. So to make sure we can see the dots, the scatter plot, we go to second, y equals. Go into plot 1, make sure everything's off. Go into plot 1 by pushing 1 or enter. Turn it on. Choose the first one, which is scatter plot. Our X is list 1 by hitting second 1. Our Y is list 2 by hitting second 2. And then you can choose if you want your dots to be boxes, plus, or dots. I choose box. Then we don't hit graph. We're going to make a window. So our window, based on our sketch we just talked about, 0 to 30, counting by 3s, 0 to maybe 1.5, counting by 0.25s. And when I hit graph, you should see the dots. And again, you can adjust the window to what you fit. Now, it looks like it has that curve, could be quadratic, so we're going to do quadratic regression. Now, all the regressions are done the same way. Stat, calculate, and then linear regression was number 4 or 8. This time I choose number 5, quadratic regression. Depending on your calculator, it may ask you for list 1, list 2 separately. This version, you have to hit second 1 for X, comma, second 2. The other version asks you the first list, the second list, you don't need the comma. Hit enter. Now it gives you A, B, and C. It doesn't have the R squared and R. We showed that in another video, but really don't need it at this point. But the R squared and the R show you the correlation, basically how the line fits with the data. But for now, here's our numbers, and I want to be very careful. A, 0.0015. B is not negative 5.78. See that E negative 4? That means we need to move the decimal 4 places to the left, so it's negative 0.000578, and C is 0.183. So you notice here, I write it out first, then I can put it in my calculator. So I go to y equals 0.000149 x squared minus 0.00578 x plus 0.1837. Now, I know I've done this correctly if that line goes through my data. So when I hit graph, it should go right through it. If not, maybe we had a decimal issue here or used that -5 or something happened here, but this is how you know if you've done it correctly. And linear and quadratic, and the other ones we'll learn, will all have that same format. So practice, practice, practice. Okay? We'll also talk about exponential functions. Exponential functions kind of like this, where it starts out low and shoots up high. It could also have exponential decay, where it starts high and goes low, but it has this general shape. Notice it's the general formula, a times b raised to the x. An example would be 2 raised to the x. There's that raised to the x that shows you it's exponential. So here's the original. If I increase the base maybe to 4, you'll notice that it grows faster. That's what's happening here. If I added a 3 at the end, notice it moved up 3. Or if I add 3 to the exponent, notice it moved to the left 3. So adding 3 goes to the left, subtracting 3 will make it move to the right. So that's generally what an exponential looks like and how it behaves. But again, this is just a quick review. We can have exponential growth. So for example, in this problem, notice exponential growth looks like the population in terms of time. You start with your initial population times a, the growth, in this case rate, raised to the t. And notice that under ideal conditions, the number of rabbits in a certain area can double every 3 months. So double every 3 months. We started with 60 rabbits. So if we just kind of work this out by hand, at time 0 we had 60 rabbits, and every 3 months that doubles to 120. 3 months doubles to 240. 9 months doubles to 480. 12 months doubles to 960. 15 months doubles to 1,920 rabbits. That's a lot of rabbits. But what it's doing, it's growing exponentially. It's not growing quadratic. It's not growing linear. It's growing exponentially, doubling every 3 months. So how would I write that? Well, by hand, remember, it's what you're starting with, 60. It's doubling, so your base is 2. So 60 times 2. But it's not doubling every month. It's doubling every 3 months. So we have to take the time divided by 3. So you're probably wondering, okay, that's how I do it by hand. Can I do it in the calculator? And the answer is yes. We can also plug in values. So just real quickly, make sure we know how to type that in. Go to y equals, clear it. We go up, enter, and make sure you turn off that plot. Start with a nice clean calculator. So if I did 60 times 2 raised, use parentheses. Newer calculators have that raised already, but just to be safe, x divided by 3. Then we've already set up our table, so when I go to second graph or table, delete what's in there, I can plug in 8 months, or I can plug in 2 years, which is 24 months, and it will plug it in for me, so it's good practice there. Okay. We can also use the calculator, and this time do exponential regression to see if we get something similar. So I'm going to work it out for you, but all the steps are here for you. And let's see what we get. So go to the calculator. If I put the data in the calculator, so I go to stat, edit. Remember, we have data in there already. So I'm going to go to list 1 all the way to the top, push clear, enter. Don't delete the list. Or you can delete the contents, but it takes a little while. So I'm going to go up to list 2, clear, enter. So in list 1, I'm going to put 0, 3, 6, 9, 12, 15. And list 2, oops, enter. And then list 2, I'm going to put 60, 120, 240, 480, 960, 1920. Make sure everything is inputted correctly, everything lines up. And then this time we're going to do exponential regression. So stat, calculate, same steps. I'm not doing linear 4, I'm not doing quadratic 5. I'm going to go to exponential, which is 0. 0. My data is in list 1, comma, list 2. Again, the other newer calculator should put list 1, enter, then list 2. And notice we get A is 60, just like our last one, and then B is 1.26 raised to the x. So you may be wondering, hey, that's different than by hand. Well, this is what we have by hand, 60 times 2 raised to the t over 3. And then by calculator, it's 60 times 1.26 raised to the x. But really, this is 2 raised to the 1 over 3t. 2 to the 1/3 t. Well, 2 to the 1/3 is the same number. So it is exactly the same thing, just done in the calculator. Okay, so we have an example of an exponential regression problem, so we'll go ahead and work this one out. So here we have new data. So let's put this data in list 3 and 4 this time. List 3 and 4. And again, we can sketch it out first by having the time as our input, job cuts as our output, and 0 to 14 would cover the top, and then let's say 0 to 14,000 would cover the job cuts. So in the calculator, I'm going to put the data in. So I go to the calculator, stat, edit. This time we'll use list 3 and 4, so we'll practice something different. And we have 0 to